If we would like to exchange data between controllers only when conditions and logic are met, we can program a message instruction into our logic. So, for example, we have a project for a high-performance compact logics controller. Looking in the controller tags, we see that there is a double integer array containing 5 elements of data. We would like to write this data to an array in another controller. Going to the other controller project and opening the controller tags, we find a destination array into which we can write our data. Returning to the controller project wherein we want to program our message instruction, we open the routine to begin programming our logic. In this example, we will simply use an XIC to condition operation of our message instruction. Then we will add the message instruction itself. Finally, we will include an output unlatch to automatically reset our toggle bit. Of course, we need to create the tag for our toggle instruction. Before we can configure the message instruction, it will require a backing tag to contain that configuration. When creating the backing tag for a message instruction, it must be created at the controller scope. Furthermore, the backing tag must be of the message data type. In addition to having a backing tag, source data, and a destination for that data, we will need to specify the path between the controllers. This can be accomplished by browsing to the controller, but only if the controller is in the I/O configuration. Otherwise, we will have to manually enter the path. So let's add the destination controller now. Now we are ready to configure the message instruction. We can access the configuration by clicking the ellipsis button on the instruction. Within the Configuration tab, we begin by specifying the type of message. Because we want to write data from one Logix 5000 controller to another Logix 5000 controller, we select SIP Data Table Write. Next, we need to specify from where in this controller the data is coming. We also need to specify the number of 32-bit elements. In this example, we have 5 double integers, so we set the number of elements to 5. Finally, we enter the name of the destination tag in the other controller. Because this tag is in another project, we cannot browse to it, and we must be certain to type it exactly as it is named in the other controller. Moving to the Communication tab, we click the Browse button, select the controller that we added to the I/O configuration, and click the OK button to configure our path. In this example, we will leave the Connected checkbox checked. This means that the message instruction will use one of the controller's connections. Furthermore, we will leave the Cache Connections checkbox checked, which causes the connection to always remain open. Clicking the OK button completes our configuration. Let's download to our controller and try out the logic. With our project online and the controller running, we can toggle our XIC to trigger the message instruction. Notice that the Done bit turns on when the instruction is finished. Let's take a look at the data in our other controller to verify that it was indeed written to. So here we see that we were successful. Notice that because the instruction only writes to the data once per trigger, we can overwrite the data. Let's return to the other project and try it again, this time with different data. And we see that we were once again successful. Now let's try reading data from a controller. Here we see that there is another array from which we can read the data. This time it contains 5 real elements. Returning to the original controller, we can construct another rung similar to the first. This time, instead of selecting SIP data table write for the type, we select SIP data table read. We are reading from a source tag in the other controller project, so we must enter the tag name manually. Then we configure the number of elements. And now we can browse to the local destination tag. In the Communication tab, we again set the path by selecting the controller from the I/O configuration. This time, let's try out the unconnected message buffer by unchecking the connected checkbox. Let's try out the unconnected message buffer by unchecking the connected checkbox. Having completed our configuration, let's download this rung to the controller and try it out. Once again, we see that the done bit turns on upon completion. Looking to the destination array, we see that the data was read from the other controller and written here. Of course, we may overwrite this data, and it will remain until the message instruction executes again. So we see that we are readily able to both write to and read from data in another controller.